Here in organic chemistry, we're going to make nylon, an example of an addition, condensation, polymerization. And you can look at the RSC, Royal Society of Chemistry site for the nylon rope trick to get detailed information. Safety, goggles at all times and gloves if you're handling the nylon product, work in a well-ventilated lab, or a fume hood. So the materials you need are pretty straightforward: the beaker, tongs, glass rod, an alkaline solution of 1,6-diaminohexane, or with cyclohexane solution of hexane dioyl chloride. And a reminder about disposal. So the nylon, you can mix any remaining chemicals, make nylon, pull it out with tongs, rinse it in water, and that can be thrown in the solid trash. And any other remaining unreacted organic chemicals in your organic disposal container. If you haven't got one, this might not be the lab for you. And you're going to pour 15 milliliters of the diaminohexane into the beaker, and follow it very carefully with the hexane dioyl chloride down the side of the test tube, and try to form 2 layers, so minimize mixing. And then when you've done that, you can get tongs and put them right down at the layer interface and pull upwards to make a thread, and keep pulling very gently to draw the thread up. And you can wind it around the end of a glass rod and keep rotating the glass rod to collect your nylon. Look at its properties, have a pair of gloves on, and you'll see a student actually touching the product that we produce. So let's go to the experiment where we're going to form nylon. So that's the diamine. That will work well.
Yesterday with two different keys. Like, you know how they sell? I had to think of it.
The trick is to pour it down so it doesn't mix. I'm going to drip some on the bench if that's on the video.
Straight right means it's volatile.
Look how it's evaporating.
It is evaporating.
Volatile.
Ooh.
Bless you.
If you come down, you'll see
Oh.
Sorry.
I want to go right to the interface.
Smells good. I love that smell. It's so toxic.
Oh
my god.
What? Who is that?
Nylon.
Nice.
That's so cool.
It looks like snot.
It looks like skim milk.
It does when
Like,
it dries over,
yeah.
yeah. I actually thought of that as you said it, so.
Oh wow.
Oops. It's going
They
to
make a sweater.
It looks like DNA. To be true.
Yeah. He's gonna sew it. I think he needs to do more. He needs to do more than that. There's more.
Does your mom know how to sew? I bet she does.
What?
Yeah.
Oh wow, it's getting thicker.
It's longer.
I probably should be pulling it up more evenly and not on the side of the vessel.
Oh, when does it end? Is it?
Never.
It doesn't.
It's like one of those clown.
Because if you keep removing the product, it's gonna keep shifting equilibrium towards the right.
Oh.
What?
I don't think it's that.
I really don't think that's it.
Oh, thank goodness for that. There's more that's there, but I'm going to run out of glass rod here. But the condensation is the so you're just going to put it down on that.
Foundations is an expertise of tensile strength. I'm sorry, I'm gonna stop.
It hasn't got much.
It doesn't have much.
You can unwind a bit if you want, and
Where do I put it? On the table?
just on the desk. Yeah, I'll do clean up here. at some stage.
Ooh.
And what we're going to do, we're just going to let that dry, and you can have a look at it next lesson. Okay?
They call it nylon.
Nylon 6/6.
Are you unwinding all of it?
No,
Yep.
we'll,
No?
we'll just leave the rest on.
Thanks for.
And then we'll show you that at the beginning of next.
nasty.
It does. So much so, I'll put that in the future.
What do you eat?
Raw lamb meat.
I'll put this
I don't think you can eat raw. No, don't eat it raw.
Today we're learning about condensation. So yeah.
And let's look at the reaction making nylon, why it's an addition-condensation reaction. And there are two reactions here. The top one is the reaction that with the chemicals that we were using, and the 1,6-diaminohexane has 6 carbon atoms. The hexane diol chloride also has 6 carbon atoms, so you end up with nylon 6,6. And if you look at the parentheses, you'll see what's inside is the repeating unit of the polymer. And the HCl is your condensation, really what is released when the two chemicals join together. And because both the chemicals have functional groups on either end, you can form very long chain. And if you have a longer, here the diol chloride, if you have a longer one here with 8 plus 2, 10 carbon atoms, you'll make nylon 6,10. And here's an example of clothing made of nylon. Look at your clothing labels to see if any of those are nylon, and look for other materials that are also made from nylon, not just clothing. And here's the repeating unit in the ball and stick model with the CO groups on both ends of the link, and here the NH2 amine on both ends. And examples of other condensation reactions deduce the structures of the polymer formed, and you'll see it later in the presentation. This is with the diaminohexane with the NH2 groups, and here carboxylic acid, a dicarboxylic acid with 6 carbon atoms. And here we're making the polyamide. R is the CH2 groups, depending on how many you've got. This can be the same number of CH2 groups or a different R dash, different one. And remember your repeating unit. And when you're joining both ends, you'll lose 2 of the here water molecules. And reminding you that the peptide bond is an addition and condensation reaction. Each of the molecules here has different functional groups on either end, and so you're joining them together with, that's your peptide link, and the water is your other condensation product. A little bit of review to read through carefully. Polyester with a dicarboxylic acid and diol, 2 hydroxide groups on the alcohol, as a little bit of Red Devil review. And finally, many thanks to Washington International School and Team Science for access to lab facilities, and to Ms. Hager's HLIB students. Thank you.